Hello, today I am going to talk about graphing logarithmic functions. So let's consider an example. Sketch the graph of a logarithmic function g of x equals logarithm with base 1/2 of x. So let's start with the graph of the exponential function. So the exponential function is f of x equals 1/2 to the x. So we can rewrite this as 2 to negative 1x, or it is same as 2 to negative x. So let's choose some values for x and find the corresponding values for the function f of x equals 2 to negative x. So if you take the x value as negative 3, then the function value is 2 to negative of negative 3, that is 2 to the 3, or 2 to the third, that is 8. Similarly, 2 to negative of negative 2, that is 2 to the second, that is 4, 2 to negative of negative 1, that is 2, then 0, when you substitute x as 0, you will get the value of the function as 1. Correspondingly, when x equal negative 1, 2 to negative 1, that is 1/2. Then if the x value is 2, then 2 to negative 2 is 1/4. And finally, if x equals 3, then 2 to negative 3, that is 1 over 2 to the third, that is 1 over 8. So we got some values for x and the corresponding values for the function f of x equals 2 to negative x. So let's plot these points and you will get a graph like this. It's like a decreasing function, and you can see that the graph is approaching towards the x-axis. And also when you look at the domain and the range of this graph, this is the exponential function. So the domain is negative infinity to infinity. That's a set of all x values. And the range is, it's approaching this x-axis, but it doesn't touch the x-axis. So you can take the range, the set of y values on this graph as 0 to infinity, 0 with a parenthesis because 0 is not included. Okay. So we got the graph of the exponential function. So we need to find the graph of the logarithmic function g of x equals logarithm with base 1/2 of x. Because this function g of x equals logarithm with base 1/2 of x is the inverse of the exponential function f of x equals 1/2 to the x, we can find several points on the logarithmic function by reversing the coordinates of the ordered pairs of the function f of x equals 2 to negative x. So since our logarithmic function is the inverse of this exponential function, the domain of the exponential function becomes the range of the logarithmic function, and the range of the exponential function becomes the domain of the logarithmic function. So we can find several coordinates for the logarithmic function by reversing the coordinates of the exponential function. So just reverse the coordinates. Then we can plot these corresponding x and y coordinates in the coordinate system. Then you will get a graph like this. Okay, so g of x equals logarithm with base 1/2 of x. So when you look at this graph, you can see this graph is getting closer and closer to the y-axis, and we can say that the y-axis or x equals 0 is the vertical asymptote for this logarithmic function. And for the exponential function, we can say that y equals 0 is the horizontal asymptote, or just the x-axis is the horizontal asymptote. Usually we need to write the vertical and the horizontal asymptotes in terms of an equation, because it represents a line, the line that is the graph approaches. Then you can see the domain of this logarithmic function. This is the graph of the logarithmic function. The domain is 0 to infinity. So 0 to infinity, 0 has the parenthesis because it doesn't include 0. And the range of this logarithmic function is negative infinity to infinity. You can see that the domain of the exponential function is negative infinity to infinity. That becomes the range of this logarithmic function. And also the range of this exponential function is 0 to infinity. 0 has a parenthesis because it doesn't include 0. So that becomes the domain of the logarithmic function, that is 0 to infinity. So we can use this method to graph the to sketch the graph of the logarithmic function.